Hello, this is Marvin Glotfelty with another industry-connected video from the National Groundwater Association. The topic I'd like to visit about today is program management. We all do projects involving installation of a well or maybe several wells, sometimes evaluation of a well, sometimes modification of a well. But a program is when we have multiple wells, a bigger picture, multiple parties involved, if things get complicated. So that brings to us some additional considerations. So I wanted to talk about that and give you a couple of examples that I've gone through, and I felt they were very instructive for me. So I wanted to share that. The first one is a few years ago in southern Arizona, where I live. I live in northern Arizona, but southern Arizona, where a mine site was going to be started. But unlike a conventional mine where they dig a large pit and excavate the ore, at this site they were going to do an in situ leaching project where they drill multiple wells. By end of mine life, there would be over 1,000 wells drilled into this ore body, inject a acid solution, dissolve the copper ore, and pump it back out as a liquid. So have a mine without the environmental impact and costly impact of removing the overburden, but rather just drill wells into it and dissolve out the ore. Kind of magic, it seems very space age, but it's been done a number of times, and it's now being done in southern Arizona. Well, at this site, this was first phase was going to be 110 wells, so a lot of wells, and they were a uncommon well design because pumping acid through them. They can't be conventional steel, and they're deep, so they couldn't be PVC because of the heat of the reaction of the acid, and also because of the depth. So at this location, it was about 650 feet to bedrock through alluvium. So we needed to have a casing in that interval, and then it would be open hole through the bedrock down to about 1,300 or so feet at the bottom of the ore body. So we have a depth of 600-ish feet, and then on down to 1,300 feet open hole. So the upper casing needed to be fiberglass stuff called, I think it's FTP, fiberglass plastic. So that is commonly used, but not so much in the water well industry. So we needed drillers that were able to handle this equipment, thread it together without galling the threads and things like that. And we needed to have drillers that could drill very straight holes, because these holes were going to be offset only 70 feet in a grid. 70-foot offset isn't great, crazy close, but with a 1,300-foot depth, it's pretty easy to have a little bit of drift to the east and the next hole a little bit of drift to the west and have problems. And for one thing, we wouldn't be able to recover all the ore. For another thing, we would have well installation problems. So how to design this well was the first challenge. That upper fiberglass casing needed to be cemented into place, and it needed to pass a mechanical integrity test per the permitting for installation of these deep injection wells. And of course, there's a lot of permitting went on, a lot of groundwater modeling, a lot of geologic modeling, and all the, of course, as you can kind of imagine, this was not controlled by anything but the hydraulic, pumping fluids in and recovering fluids out. And so a lot of monitoring going on, a lot of considerations of this. So a really interesting project. And then the selection of the driller. And actually I should say drillers, multiple drillers. This is a lot of wells. In the first year to drill 110 wells, that's very aggressive. And so how to do that? So we had an extreme vetting process. We invited 7 drilling firms to submit proposals, I should say, not just bids, but proposals, because this was going to be on a a unit cost basis, lots of things going on. You can't just say, what's the bottom line? There's nothing lump sum about this job. And so what would be, we needed to know that they were going to provide the level of quality. So we asked each of them to provide a package with their driller's license, their state driller's license, resumes of their supervisors, drillers, and safety personnel, references from recent clients, their maintenance records from providing maintenance on their equipment, their drilling fluid control equipment, air packages when they're drilling with air, pipe handling equipment, so on and so forth. Lots and lots of information. And then we made a short list, and we interviewed a 2-hour interview with each of the shortlisted firms, and then finally selected several firms for the work. So that's a very extensive, not only vetting of the drillers, but also an unusual design of these wells, and needed to be something that could actually be achievable throughout this project. Today, copper is actually being coming out of the ground through this process. So it's in place. The first phase is in place. More phases are proceeding. It's going very well, to my understanding. So that required a lot of coordination with the mining client with whom we worked to make them understand the opportunities and limitations of a drilling program such as this, and also interaction with the drillers to be sure we had a fair and appropriate vetting process for selection of the driller. So that was the first example of a program management job that I was involved with. The second one was for a municipality. The city of Phoenix, where I live, needed to be aggressive to install more wells to fill in its groundwater portfolio. So over the years, they had, Phoenix was already underway with a very good program to put in aquifer storage and recovery wells, or ASR wells, so that we could stabilize water levels in area of overpumping, utilize excess surface water from the Colorado River or other sources when we had it, to inject it in the ground, store it, and then pull it out during times of need. Well, this program was to put in a 3-year period, and from design to operation, 10 wells, of which 7 would be ASR wells, and the other 3 would be production wells. Well, that's very aggressive. How are you going to do that? So to do it, the city selected my firm and another engineering firm to be the program managers. And we worked together to manage all the other design consultants. And the design consultants, there were 3 other firms. One firm that was both engineering and hydrogeology. The other 2 firms had a engineering firm that subcontracted the hydrogeologist. So the hydrogeologist would install, design and install the well. The engineering firm would do the above ground infrastructure, SCADA, all that business. So we had 3 different consulting firms. We had 2 general contractors, construction manager at risk firms, and each of those 2 firms subcontracted multiple drilling firms. So we have quite a herd of chickens to push along here. We have 3 consulting firms, well, actually more than 3, but 3 hydrogeology firms, and then some additional engineering firms. We had 2 general contractors, and we have multiple drilling firms. And over a year, we had 2 to 3 rigs running at all times to get these 10 wells in. They are all on the ground and all functioning now. One of them turned out to be a dry hole that would not produce enough water. The area that we worked in is actually pretty robust. Most of these wells, all of these wells, are between 1,000 gallons per minute and 3,000 gallons per minute. Many of them over 2,000 gallons per minute. This one well would have only produced, we predicted, about 300 gallons per minute, so it was not completed. It was drilled, tested, but not completed because of the location it was at. So as going forward, the program management responsibilities were to first make a guidance document. Everything has got to meet the city standards. So in this case, that meant stainless steel screen interval, dissimilar metal connector to a high spring flow alloy upper casing, just to save a little money, glass bead filter pack, a lot of exotic stuff that wouldn't be used elsewhere, but because of the needs and the location and the history in this area for this municipality, that's what was done, and it worked very well. So, so we started with these guidance documents. Every consultant did their own technical specification on a well-by-well basis. I reviewed each one of them, provided input, and then they were finalized. The drillers drilled the wells, and there was interaction along the way there. And then the final report, I reviewed each one of those. So there was a lot of lessons learned through this process. And one was, when you are a program manager, you need to broaden your perspective a little bit. You can't have this my way or the highway approach to things. I like the way I design wells, of course. Others may disagree, and that's fine, because there is the art of it. There is that part of it where it's not 1 + 1 = 2. It's not so clear as that. Another consultant may have a different way to design wells, or a different time period, maybe on well development, or maybe on testing, or things that they like to emphasize. If they're not wrong, then they shouldn't be changed. If it's not broke, don't fix it. And so I was put on a nice learning curve about how to be firm when it makes a difference, and not firm when it doesn't, and respect other professionals. Again, you got a lot of professionals involved here, a lot of the multiple drillers, multiple consultants. Of course, there's going to be some headbutting, right? And I was going to get a lot of phone calls. The level of communication has to be enormous. So there's a lot of CCs on emails, and those emails are indelible. You must always remember that about emails. They can always come back, and people say, well, you said this, and now you're saying something different. So it's important to be fair and to be open to suggestion and communicative. So this was a real good experience for me. I think that a lot of us, as time goes on, groundwater becomes more and more important, not less. We will find ourselves in positions like this, and so it's good. Like next week, maybe I'll be in a more subordinate position where somebody else is my program manager, and so I'll have a different hat on, and that's good. That's the way it ought to be. People shift around, we fill in different positions, but we all work together for the better good, for getting that groundwater resource developed, used, so that communities, mines, or whoever's going to be using it can have a good water resource. Thank you very much for your time. Talk to you next time.